similar triangles. Similar triangles work just like normal similar shapes, but they do have some extra little rules for checking whether the shapes are similar because of the way that triangles work with 3 angles and 3 sides. There's 3 different ways to prove that 2 triangles are similar, and we're starting with the angle, angle, angle rule. That is, that matching angles, there's 3 pairs of angles in the 2 triangles that are equal. Now there's a few different ways to show that there's matching angles in a pair of triangles. In my first set here, we are given all 3 angles for both triangles A and B. I've got a pair of 40 degrees, a pair of 80 degrees, and a pair of 60 degrees. Now the thing about triangles is that we don't actually have to show, if we know all 3 angles, we don't actually have to show that 40 degrees and 40 degrees match. Sorry about that. We don't have to show that they match. There's only 3 angles in the triangle. If all angles are equal, then the matching ones are the same, and these 2 triangles are similar. We can use a symbol of a triangle and the letter that belongs to the triangle to name triangle A and triangle B, and there's a symbol that means is similar to, and it's 3 vertical lines. It's like an equal sign with an extra line but turned up vertically, and that means is similar to. In the same way as an equal sign means is equal to, this is the sign that means is similar to. So if we see 3 angles in triangle A and the same 3 angles in triangle B, then we know that those 2 triangles are similar, and we can say so. The next pair, triangle C and D, you'll see we don't actually know what all the angles are, but they've been marked with symbols that show they're the same. So I've got a 90-degree angle in each triangle, and the other 2 angles are marked with matching symbols which say we don't know what these angles are, but we know that matching symbols give us matching angles, so I can say in this one triangle C is similar to triangle D. I could write that in words. C is similar to D if I wanted. So 2 different ways there of seeing that triangles are similar because they've got matching angles equal. But a couple more examples. Let me just move my screen. 3 examples here. Look at triangle E and triangle F. They've given me some angles, but not all of them. Now in triangle F, we know that the angle sum of a triangle equals 180 degrees. That is, all the triangle's angles added up must equal 180. So if I've got 2 of the angles, I find the third one by taking 180 degrees and taking away both of the other angles. 180 degrees minus 120 degrees is 60, minus another 30 degrees. That tells me that my other angle is 30 degrees, and I can put that in. So if I have two angles of a triangle, I can find the third one. What about triangle E? I've only got one angle. In triangle E, we need to remember our triangle rules. The fact that two sides are the same on triangle E means this is an isosceles triangle. And if we're being very clever, we can remember that the rule about the isosceles triangle is that the two angles at the base of these two lines that are the same will be equal. So this angle here will also be 30 degrees. And we know from before, in triangle F, we had two angles of 30 degrees and the other one was 120. So that would be a shortcut if we wanted that this angle in E is also 120, but I could work it out by doing 180 minus those two 30-degree angles, which is 180 minus 60, which is 120 degrees. So I've finally got all three angles in both triangles, and the three pairs of angles are the same, so I can say triangle E is similar to triangle F. Sorry about the delay in my writing. I'll get better at that. Let's just tidy up here. And the last two pairs of triangles, they're getting really tricky. These need us to remember our parallel line and angle rules. Having a look at this first one, there's two triangles, a little one that's overlapping a big one. Now, that means that angle A in both the triangles has to be the same in the big triangle and the little triangle because it totally overlaps. So you can always look for totally overlapping angles. They'll have to be the same. And it gets a little tricky, but you'll remember that a pair of parallel lines with another line through them gives us things that we know about the angles in there. For example, corresponding angles, angles in the same position on both the parallel lines, are equal. And we can see that angle B and angle D are in the same position on those two parallel lines. They must be equal. And the same goes for angle C and angle E. They're corresponding angles, they're in the same position on that parallel line pair, so they must be equal. So even though we don't know any of the angles, we can say that the little triangle is similar to the big triangle. Now you'll see that they haven't named these triangle A and triangle B. They've given each of their corners a name. That means that's how we name the triangle. The little triangle is triangle ABC. We name the triangle after its 3 corners. And the big triangle is triangle ADE, because those are the corners of the big triangle. And so those are officially the names of those triangles, and we can say that triangle ABC is similar to triangle ADE. Last example, very quickly because we're running out of time. The angle C that's made by crossing over lines in my last pair of triangle. Remember, if I've got 2 lines that cross over, they make vertically opposite angles, which are equal. So those 2 angles are equal. And when I have a pair of parallel lines and a line going through them, remember there are alternate angles which are equal. Angle on that side of the line and that side of the line. Oh, marking those. Yep, there they go. So angle B equals angle D, and angle A equals angle E. So these are a bit trickier. They need us to remember our parallel line rules, and then we name our triangles. Triangle ABC is similar to triangle CDE. Lots of different ways that we can show that all 3 angles in the 2 triangles match up in equal pairs.